Welcome back, everybody. This next section, 1.5, continues the concepts that we've been working on for the last two sections. Just like numbers, with functions, you can add, subtract, multiply, and divide two functions. Let's jump into a first example. Let's say f of x equals 2x squared plus 3. G of x equals 4x cubed plus x squared plus 1. All right. So basically what we need to do is we need to figure out how to add these two things up. Well, the way I'm going to start is I'm going to say I want to add f of x plus g of x. All right, and then I'm going to do a substitution. Basically, I'm going to take this, which is f of x, and put it there. And I'm going to take this, which is g of x, and put it right here. So I'm going to rewrite this as, and they're both quantities, so you can put them in parentheses if you need to. It might be helpful. 2x squared plus 3 plus 4x cubed plus x squared plus 1. The parentheses don't necessarily affect anything in addition, but they do in subtraction. So getting the habit of putting in these parentheses could really be helpful. Now it's just a matter of matching up your like terms. I just have a plain old 4x cubed. I have 2x squared plus x squared, which is 3x squared. Plus 3 plus 1 is plus 4. All right. So again, the thing you want to remember with addition is you always want to add your like terms. Can't add 4x cubed with 2x squared. They're different. All right. Now, as I said, the parentheses come really handy when you're talking about subtraction. So let's take a look at the similar type problem and just say we want to, instead of f of x plus g of x, I want to do f of x minus g of x. I'm going to start by putting my 2x squared plus 3 minus 4x cubed plus x squared plus 1. I'm going to scroll up a little bit just so we're clear on what's going on. So I'm going to give you a chance to take a look. Notice that we have a negative sign and a parenthesis, so that has to be distributed. Why don't you pause the video and take a minute to distribute, and we'll talk about our answer on the back end. All right, so hopefully you worked your way a little through the problem. You have 2x squared plus 3 minus 4x cubed minus x squared minus 1. And now it's an addition problem, so you just have to match up your like terms. So I have negative 4x cubed plus x squared plus 2. All right, so again, the only step you have to put on top of this for subtraction is distributing that negative first, and then it's just a matter of adding like terms. All right, let's take a look at multiplication. I'm going to use the same f of x and g of x, except I'm going to say f of x times g of x. So then I have 2x squared plus 3, 4x cubed, plus x squared, plus 1. And now we're going to use what you've come to know as distributive property. I like to write out my distributive property. I think it helps. If I'm going to take 2x squared and multiply it times everything in the second parenthesis, I'm just going to write that out. Then I'm going to take my plus 3 and I'm going to multiply it times everything in the second parenthesis. All right. Very often people talk to me about how much do you need me to write out? How much work do you need? Well, I find that when students say that, they want to keep a lot in their head. And that's when mistakes happen that they could help. I think this step is really, really helpful. Try it out. You might like it. All right. So at this point, now we can just take a single term and run it through. So now I have what? 8x to the 5th plus 2x to the 4th plus 2x squared plus 3x, not 3x, just kidding about that, 12x cubed, 3x squared plus 3. And at this point, we have an addition problem, which means that we're simply looking at combining like terms. So I start with my leading exponent. I just have 1 to the 5th power, so it's 8x to the 5th. Then I have 2x to the 4th, no other x to the 4ths, so that's plus 2x to the 4th, 12x cubed, plus 5x squared, plus 3. All right, so kind of doing it systematically really helps. And writing out the extra step, I think, makes things much, much easier. For division for right now, I'm simply looking for a stacked fraction. So if I wanted to find f of x divided by g of x like this, you would simply write your 2x, not 2x cubed. I was looking at the plus 3 already. 2x squared plus 3 over 4x cubed plus x squared plus 1. And basically, the only thing you need to do is check to see if it can be simplified. If it can be simplified, you should. If it can't, you shouldn't. And just as a reminder, the commutative property still applies when you're talking about functions. It's addition and multiplication, as when you are talking about numbers. All right. So let's move forward to the next topic, which is going to be average rate of change. Now, this is going to be a one-section topic. However, if I were you, I'd put a little gold star next to it, because when you get to Calc 1, you're going to spend half the semester dealing with average rate of change. All right, so put a little star next to it. It's going to be an important topic. Now, average rate of change means slope. If I'm asking you the average rate of change of sales, I want to know the slope of the sales line. All right, so anytime you see average rate of change, you could say find the slope. All right, so if I had 2 points, you have to have 2 points to find a slope. If my x-coordinate was a and b, if I took a, let's say, and I run it through my function, my y value would be f of a. If I took b and I ran it through my function, my y value would be f of b. So the slope formula would look like f of b minus f of a over b minus a. And again, this is the slope formula that you're used to, except you're used to the, I'll use a different color. At y2 minus y1 over x2 minus x1. It's the same formula, just slightly different notation. All right, so I'd like to try to do an example and just kind of show you what I mean about some basic problems dealing with average rate of change. All right, so let's say our f of x equals, I'm going to do a small function, 3x, make it reasonable, 3x squared, and I want to find the average rate of change from 1 to 3. All right, now the first thing we need to figure out is this 1 and 3 in the problem are both x values, right? If we're basically, the minute we see average rate of change, we need to find slope, which means we need 2 points. Well, 1 and 3 from the problem are the x values of the 2 points we need. Now the question is, we need the y values. So I got to take this 1, here I'll use a different color, and I want to put it into my function, and then I want to take this 3 and I want to put it into my function. So at this point, why don't you guys stop the video, take a moment, run 1 through the function, run 3 through the function, and we'll see what our y values are. Then come on back, we'll do a little bit more. Okay, hopefully you ran these through the function. I got a y value of 3 here, and I got a y value of 27. Now, if we're looking for average rate of change, basically it's saying find the slope. So I can do y2 minus y1 over x2 minus x1, which means 24 over 2, which equals 12. All right, so this is the average rate of change from 1 to 3. And if you're asking me, I'd always like to see a small sentence saying exactly that. So it just makes sure that I know that you know what the context of the problem is. All right, let's try one. We'll let you try it a little bit more on your own. We'll definitely go through the answers, so don't worry. But let's say our function is still 3x squared. And I want to get the average rate of change from 1 to 5. All right. So our first step, again, I'm going to set up my 2 points, 1 and 5 right here. Now we already know that this is 3 because we know that from the last problem. If you didn't get this in the last problem, take 1, run it through again, make sure you get your 3. All right. At this point, why don't you pause the video? You know what? Let's see how far you can take it. All right. If you can take it all the way, come on back, and I will go over how I did it as well. If you can't, you're stuck, definitely come on back. I'm still going to show you the same stuff. All right, so I got 75 when I took 5 and I ran it through my function. So as long as you got the same thing, let's put the numbers right into our slope formula and find that average rate of change. So I got 75 minus 3 over 5 minus 1, which is 72 over 4, which if you simplify it is 18. So again, same type of thing. I would love to see a sentence that says 18 is the average rate of change from 1 to 5. All right. The last thing I want to talk about a little bit is something called the difference quotient. Now, the difference quotient if I told you to put a star around the topic earlier, right, over here with average rate of change, the difference quotient gets 2 stars. And the reality is that this is beginning calculus. without the calculus. This is without the calculus part. All right. This is a way to get you comfortable with all the algebra you're going to need to do. All right. And then next semester, we will bring the calculus into this, but you guys will be experts in working through the algebra. All right. So this is the difference quotient right here. You got to know it. All right. If I ask you for the difference quotient, all right, I definitely would say you got to know it. There's no way that you're going to know how to do this without having this model in front of you. All right. So I think the best way to kind of explain how to do the difference quotient is with an example. All right. So here's my example. I'm going to say f of x equals 2x squared minus 3x plus 5. All right. So as we're okay. So the first step I want to do is I want to find f of x plus h. All right. Now, like I said, people try to take on too much a lot of times. Let's just focus on one thing, finding f of x plus h. So if I want to know f of x plus h, I'm going to start by rewriting my function with just parentheses there instead of an x. And again, the reason I do this is I find it gets confusing to have an x there and then substitute in something else. You got to remember that x is really a blank spot for anything you want it to be. Now, I happen to want it to be x plus h. So I'm going to put x plus h right into that parenthesis spot. And now basically what I'm going to do is I'm going to do a little bit of algebra to make this just a little bit more simple. So I have 2 times x plus h minus 3x minus 3h plus 5. Then I'm going to do the FOIL here. So I have 2, so that's x squared plus 2xh plus h squared. I definitely encourage you to check my work. Minus 3x minus 3h plus 5. The last thing I'm going to do before I do any more of this problem is I'm going to say and distribute that too. So I have 2x squared plus 2xh plus h squared minus 3x minus 3h plus 5. All right. This is kind of a long problem, but if you do it in stages, all right, things should be fine. So stage 1 is complete. Now, so this is stage 1, and I'm going to use a different color to highlight that. So I'll use green. I used green already. So there's stage 1. Now stage 2 comes here. Now what stage 2 consists of is subtracting my quantity f of x. All right, if we think we have a long string of stuff right here, it's going to get a lot shorter when I subtract my quantity 2x squared minus 3x plus 5. Because what I'm going to find out, I'll use my highlighter just, all right, is I have a 2x squared here minus 2x squared. I have a negative 3x minus a negative 3x. So they basically go away. I have a positive 5 minus positive 5. So I've got a whole bunch of stuff that goes away. That's great. That's exactly what I want because I want everything left to have an h in it. 2xh plus h squared minus 3h. Now, I look real quick. Everything has an h in it. I'm feeling pretty good about where I am. It doesn't necessarily guarantee I've done everything perfectly, but if everything doesn't have an h in it, something went wrong, which means you're probably better off going back to the previous step, all right, rather than moving on, because if something's wrong here, it ain't going to get fixed later. All right. Now, this right here is stage 3. All right. So again, I'm going to use green to highlight the stages. Stage 3 says I want to divide everything by h. Now, if I want to divide everything by h, here's the way I'm going to do it. And I'm going to put in one extra step, but this one extra step I find really helps students. So I definitely encourage you to use it. All right. I'm going to look at my numerator and I see that I have an h in everything. So I'm going to factor out an h and I'm left with 2x plus h minus 3 all divided by h. Now at this point, we have a very easy cancel cancel, and I'm left with 2x plus h minus 3. Like I said, this kind of takes a long time. However, if you're writing out everything just the way I did, it really isn't that bad, and you really wind up saving yourself a lot of heartache with some errors. All right, so that's it for now. There's definitely more practice ahead of you. Here, I'm actually, you know what? I'm actually going to do one more with you guys. So if I say I want to find the difference quotient, here I'm just going to give you a very quick f of x equals 1 over x. If we wanted to find the difference quotient, the first stage would be f of x plus h, right? So f of x plus h minus f of x all over h. There's my 3 stages. All right, so my first stage says 1 over x plus h. That's this, right? So that is stage 1. Now, is there any simplifying to be done? There really isn't. This is as simple as it gets. All right, so then stage 2 is over here. I want to subtract 1 over x. Now, I can work with this because I have a fraction that's subtracted. Basically, what I need to do is I need to make a common denominator. So here's what I want you to do. I want you to pause the video for just a minute, work through that common denominator because all of you have done common denominators before, and we'll talk about the answer on the back end. All right. So if I have 1 over x plus h, I'm going to make a little extra space, 1 over x. I'm going to multiply top and bottom times x over x. And x plus h, x plus h. And that's the way I'm going to get my common denominator. All right, so then I wind up with x minus x plus h all over x times x plus h. All right. So when I subtract my like terms, I wind up with negative h over x times x plus h. Now notice I didn't multiply the bottom. You're not required to multiply the bottom, all right, especially if the directions tell you to do everything in factored form. All right, so now I want to divide. Now I want to move on to stage 3. Stage 3 says divide by h. So if I'm dividing two fractions, really what I'm doing is I'm multiplying times 1 over h. All right? And if I do this, I find I can cancel, cancel, and I'm left with negative 1 over x times x plus h. And as far as I'm concerned, you're done at this point, right? Looked like a fairly complicated problem that was solved actually much quicker than the first example we did. All right? So at this point, I'm going to stop it here. There's much more practice to be done. I look forward to seeing you soon.